Assalamualaikum warahmatullahi wabarakatuh. We have given a task to review an article and make a report about tool wear and failure monitoring technique. Cutting tools are subjected to an extremely severe rubbing process. They are in metal-to-metal contact between the chip and workpiece under high stress and temperature. Tool wear is generally a gradual process due to regular operation. Tool wear can be compared with the wear of the tip of an ordinary pencil. For this report, we will review articles of tool wear and failure monitoring technique.
Assalamualaikum warahmatullahi wabarakatuh. I'm Lufil Hakim. Today I want to talk about the abstract. Okay, in the metal cutting, there are different toolway mode and their rate play vital role in overall production performance. For a given tool, premature failure of tool can cause unexpected machine downtime and material losses, while another tool could serve beyond the preset life. Okay, by using this technique, which is called the tool condition monitoring (TCM) system, and this system can improve the output and prevent any losses.
Today, I want to present to you about tool wear and failure monitoring technique. So, the article that I choose is tool wear detection and fault diagnosis based on cutting force monitoring. The writer for this article is Sunan Huang from National University of Singapore and Han Leong Goh from Integrated Health Information System. The year for this article published is on March 2007. The objective of this experiment is to sense the loss in original function of tool in order to detect an abnormal state. The machine used to run this experiment is CNC machine, which is milling. So how the machine works? The workpiece will move horizontally driven by x-axis and y-axis motors, while the tool moves vertically driven by z-axis motor. There are sensors used in this experiment, which is force sensor and dynamometer. Dynamometer is used to measure torque and to measure rotational speed. So the figure above is the CNC machine. So you can see the dynamometer is put bottom of the machine, so it can measure the torque and the rotational speed. So then we run the experiment for several times with this different parameter, which spindle speed, feed rate, and depth of cut. The graph shown is a comparison of actual and estimated cutting force. For the first one is A is with spindle speed 800 RPM with feed rate 150 mm per minute with depth of cut 1 mm. B is spindle speed of 1000 RPM with feed rate 100 mm and per minute, depth of cut 1 mm. C spindle speed is 1000 RPM with feed rate 200 mm per minute with depth of cut 1 mm. And the last one is spindle speed 1200 RPM with feed rate 200 mm per minute with depth of cut 1 mm. They show the least error for
Warahmatullahi wabarakatuh. I'm Lufil Hakim bin Abdul Hadi. Okay, today I want to review about the article. Okay, this article, the title is Integrated Tool Conditioning Monitoring System and their Application. Okay, this article have been done by Chandranath Industrial Innovation Laboratory and Hitachi America R&D Division. Okay, this article was published on year 2020, and this article is about how to monitor the tool condition and by using the offline direct method. Okay, by using this offline direct method, okay, this can be used by using the optical measurement, which is to check the condition of the tool by using the optical microscope to check the condition. Okay, then we can check whether the tool have chipping, breakage, notch, chatter, or etc. Okay, and next is This inspection process take a long time, and the machine have to go to either state which is can cause the time longer than expected. Okay, to conclude that this method is very accurate, but it is too slow response or processing time, and the result also misleading because of the cutting force variation. Okay, for the next step is the temperature. Okay, why I tell the temperature, because the temperature is one of the thing that happen during the cutting between the tool and the workpiece. Okay, when the temperature cutting increase, the chemical dissolution of the tool material also increase. Okay, by using this method, which is called the developing mathematical model. Okay, this model can be estimate the wear rate and the temperature, but it is so hard to predict the wear length and require of a database of the thermochemical properties of the specific tool workpiece. Okay, the temperature core at the tool tip, which is very small, usually around 0.5 to 2 mm, depending on the parameter, which is the maximum temperature is produced. To conclude, the temperature data acquisition method is not so useful for the tool conditioning monitoring system in manufacturing production.
My name is Muhammad Khairul Azhan bin Muhammad Safian, and I will explain about my article, which is real-time cutting tool condition monitoring in milling. Reliable tool wear monitoring system is one of the important aspects for achieving a self-adjusting manufacturing system. The original contribution of the research is the developed monitoring system that can detect tool breakage in real time by using a combination of neural decision system and AFIS tool wear estimator. The principal presumption was the force signals contain the most useful information for determining the tool condition. Therefore, the AFIS method is used to extract the feature of tool states from cutting force signals. The AFIS method seeks to provide a linguistic model for the estimation of tool wear from the knowledge embedded in artificial neural network. The AFIS method uses the relationship between flank wear and the resultant cutting force to estimate tool wear. A series of experiments were conducted to determine the relationship between flank wear and cutting force, as well as cutting parameters. Speed, feed, depth of cutting, time, and cutting force were used as input parameters, and flank wear width and tool state were output parameters. The force were measured using a piezoelectric dynamometer and data acquisition system. Simultaneously, flank wear at the cutting edge was monitored by using a tool maker's microscope. The experimental force and wear data were utilized to train the developed simulation environment based on AFIS modeling. The artificial neural network was also used to discriminate different multifunction states from measured signals. By developed tool monitoring system, the machining process can be online, monitored and stopped for touching based on preset tool wear limit. The fundamental limitation of research was to develop a single sensor monitoring system reliable as commercially available system, but 80% cheaper than multi-sensor approach.
The conclusion that I can make from this experiment is a fault detection method is proposed based on the cutting force of the monitoring automated machine. There are disadvantages of this experiment, which is the limited bandwidth of the sensor. The second one is impractically of the dynamometer, and the last one is the influence of the spindle speed on the measurement accuracy. That's all from me. Thank you.